When adding and subtracting complex numbers, you want to add and subtract the real and imaginary parts separately. Let's find a common denominator between the real parts. They each can have a common denominator of 10, so 3/5 can be rewritten as 6/10. For the imaginary part, 8 and 6 both go into 24, so I will rewrite each of them over 24. The 1/8 becomes 3/24. The 1/6 becomes 4/24. So when I go to combine these together, adding the real parts together, I'm going to get 6/10 minus 7/10 plus, and then I'm going to have negative 3/24 minus 4/24 I. Combining the fractions together within each parentheses, we now have negative 1/10 minus 7/24 I. Notice how our answer is in A plus BI form. In this next problem, we want to use the FOIL property. So the first term of FOIL, 2 times 8 is 16. The outer term of FOIL will become plus 4i. The inner term will become minus 40i. That should have been my I. I'll put my I down below. And then the L term will become minus 10i squared. That gives us 16 minus 36i minus 10 times negative 1. Negative times negative is positive, so this last term is plus 10, and I can rewrite this expression as 26 minus 36i, again in A plus BI form. Okay, first we want to, in this next problem, identify the complex conjugate. That's what we get when we change the sign in the middle. So we're going to have part A, 4 plus 5i is the complex conjugate. Now it turns out that whenever you multiply A plus BI times A minus BI, you are going to get A squared from the first part of FOIL. The middle terms of FOIL are going to cancel each other out, and you're going to get minus B squared I squared, which turns into plus B squared. And that is a much quicker way to allow us to multiply conjugates together. Because when we now multiply 4 minus 5i times 4 plus 5i, we're going to get 4 squared plus negative 5 squared. This will become 16 plus 25, which is equal to 41. A squared plus B squared. An expression is not considered simplified when it contains an I in the denominator, because technically I is an imaginary number. So we want to multiply in this case by 11 minus 4i over 11 minus 4i. Multiply by the conjugate of the denominator over itself. Now when we do this, down below we're multiplying conjugates together, so we're just going to have 11 squared plus 4 squared, as we saw in the problem above. Up above in the numerator, however, we've got to do a full distribution. The first term of FOIL is 110. The outer term will give us minus 40i. The inner term will be minus 33i. And the last term will be plus 12i squared. Okay, our denominator is 121 plus 16. And the numerator will become 110 minus 12. That's 98 minus 73i. When we combine over this denominator of 137, we now have 98 minus 73i over 137. Technically that's not correct because it's not in A plus BI form, so I want to rewrite this as 98 over 137 minus 73 over 137i.